This is the first revision video for section 2.2 Everyday Consumer Products, and in this first video we'll look at alcohols. Alcohols are the first homologous series that we've come across that are not made up entirely of carbon and hydrogen atoms. In the first section 2.1, alkanes, alkenes, cycloalkanes were just made up of carbon and hydrogens. Alcohols also contain oxygen. In fact, what they contain is the hydroxyl group. So the functional group in an alcohol, which gives its distinctive properties, is the hydroxyl group. So the first member of the alcohols is the one with one carbon. So it's like methane, only one of the H's has been replaced by a hydroxyl group, the OH. So instead of calling it methane, we lose the final E and stick on an OL, so it's methanol. It's also fine to draw it like this without actually showing the bond between the oxygen and the hydrogen. So both those ways are perfectly acceptable structural formula for an alcohol. If you have two carbons, you've got ethanol. If you've got three carbons, you've got propanol. But once you get to three carbons, you've got a choice of where you put the hydroxyl group. Do you put it on the number one carbon or the middle carbon? And so on. After propanol, you always have that choice. So let's look at a couple of isomers of butanol. Okay. So 4 carbons, an OH group. So in the top example, the OH group is attached to the first carbon. Obviously, we need a number from the end that gives us the smallest number for the hydroxyl group. So that would be, instead of just being butanol, butan 1-ol. Whereas in this case, the hydroxyl group is on the second carbon. So this would be butan 2-ol. Please note that when you don't show the bond between oxygen and hydrogen, it's imperative that the bond going from the carbon to the hydroxyl group goes to the oxygen, not some vague place in between the oxygen and the hydrogen. It must bond directly with the oxygen. Okay, what about the properties of these alcohols then? The first thing that's worth commenting on is the solubility. Now remember the alkanes, alkenes and cycloalkanes that were just made up of carbons and hydrogens were all insoluble in water. What we find that for the alcohols is that the small alcohols, in particular methanol, ethanol and propanol, are soluble in water. The way I like to think of it is, because they've got that OH group, they've got something similar with water, because water's kind of got two OH groups. So the small ones are similar and have enough in common with water that they mix well with it. So methanol, ethanol and propanol all mix very well with water. But as the alcohol gets bigger, you're just increasing that hydrocarbon part of the chain, just more CHs, and it gets less and less in common with water. And so as the size of the alcohol increases, the solubility in water decreases. Okay, here I've got 2 test tubes with water in it. I've just put a little bit of food colouring in it just to make it more visual. Okay, so in the first one, so this one here, I'm going to put a small alcohol, ethanol, into it, and we should see that it mixes with the water. So give it a wee mix up. And what you see is the ethanol and the water has mixed. There's not 2 distinct layers. Now you should know that from seeing a glass of wine. You don't see 2 distinct layers in a glass of wine. So small alcohols dissolve in water. In the other one, I'm going to put a larger alcohol, octanol. Okay. And give that a wee mix up. And what you see is you have got two distinct layers. The octanol is not soluble in water, and so you get these two immiscible layers, meaning that they don't dissolve in each other. So small alcohols dissolve in water, large alcohols do not dissolve in water. Okay, let's move on to look at melting and boiling points of the alcohols. Well, here they've got an awful lot in common with the previous homologous series. The fact that the main thing you have to know is the melting and boiling points increase with the size of the molecule. So as the size of the molecule increases, you get a stronger attraction between the molecules, and so it's harder to melt and break and boil them. And the third useful property of alcohols is that they're very flammable. So let's look at how that leads on to their uses. Well, obviously alcohols are used extensively in the food and drink industry. Of course, there really we're just talking about ethanol. But industrially, alcohols are used quite a lot as solvents because they dissolve a lot of substances that water doesn't dissolve. So let me give you a quick demonstration of that. Okay, so here we've got a structural formula for ethane written in a permanent marker. Now, all a permanent marker means is it's something that's not soluble in water. So I've got a cloth here soaked in water, and as you can see, it has no effect on the permanent marker. But if I get a cloth soaked in alcohol, hopefully it will remove the permanent marker. Okay, so you see that the substance didn't dissolve in water, but it's very soluble in alcohol, and that is quite common for lots of substances. And so industrially, a lot of the times we use alcohols to dissolve things. And a third use of alcohols is, of course, as a fuel. They burn very well, as we know, and so this can be used to provide a lot of energy, so it's a good fuel as well. As mentioned, alcohols are of course very flammable, and this means that they're used an awful lot as a very useful fuel, as an alternative maybe to fossil fuels, and also can be used for cooking, camping, stoves, etc. So very, very flammable. Okay, 3 things you must be able to do. You should be able to recognise and name members of the alcohols with up to 8 carbon atoms. You should be able to identify the hydroxyl group in an alcohol, and you should recall the properties and uses of alcohols.